Lego is, as I mentioned already, front-end game for iGaming casino provider who are one of the first to start building web-focused slots, and you might know it for games like Book of Dead, React Tunes, or Moon Princess, which are the biggest hits of Lego. Today we are going to talk about three main aspects of it. It's intricacies of engine development in web game development and iGaming industry. We will cover some fundamental concepts of the building game front-end game engine, and we will review some pros and cons of building your proprietary engine versus using a third-party one. So give you some overview of these topics. So when coming to the intricacies of the building an architecture for your game development, I would say that my main take is do or do not. There is no try, because when the worst thing you can do to your future's company is improvise when it comes to front-end architecture, especially in the gaming industry. Because, like, I would say it's a very approximate made up statistics, but 9 of 10 companies would probably not care about front-end architecture when they start building games, and one left probably never followed up on it and just watched as it broke down with time. We will talk about why this is happening in a bit. But yeah, the harsh truth is architecture is hard and expensive, but well, we can go too far without it. Like, to tell you a bit in a formal story, if you have like built a game because you want to break into the iGaming industry, so you build a slot. That's perfect. You have a first game, it's successful, but there are multiple factors that will build requirements for your game. Like, first of all, like casinos, you need to integrate your game into casinos, and you want to work it in as many casinos as you want. And all of them, most of them, need different level of integration. Some more complicated, some much less complicated, but still they are different. And you need to take a look into it. Also, browser support. It's a web game, so it's all run in browsers, and there are different of those. Some basic, like Safari, Chrome, Firefox, Edge, just to name the main major ones. There's much less popular ones that more unique to different applications that you probably also want to support, and they can be quite different from what you expect from. Because yeah, it's not like you can just build it, test it with Chrome, and be good about it. Then you need to think about platform support, because you want to work it on desktops that are also different. You can have Windows, Mac OS, Linux. They can be powerful, they can be crappy one. So you also want to work in mobile today, and mobile also. You have Android, you have iOS. God forbid you have Windows Mobile someday before, and stuff like that. And that's also you need to think about. And in the specifics of the iGaming industry, you have compliance. And that's also about jurisdictions that are many, and you want to launch in as many as you want. And all of them will have different requirements for your games to run. And the worst thing about it is they change. They change constantly, they change independently between each other, independently for your plans. And the next thing is when you build a game, then you build another game, then you build another, and like, you do it all the time. That's one of the specifics of iGaming business. You continuously build more and more games. And in the end, like Go today, this year celebrates 50th anniversary, and they have like almost 400 games, and they want to develop more than 50 games every year. So you can imagine that it's quite a portfolio. And when something of I mentioned earlier changes, it can break your games, or your games can become not compliant anymore, but you want still them to run. So you need to make some changes in like 400 games. And you can understand that if you never thought about front-end architecture before, you will find out yourself in a very complicated situation. So, yeah, when it comes to front-end architecture, people usually tend to underestimate it. But the fact is, if you do it, later on you will find yourself every change is very painful, very expensive. And other companies that only start, they can learn from your mistakes and they can be much faster than you. And then there is very bad prognosis can be done. So yeah, think about early, it will be much cheaper than later. Now we will take a look into fundamentals of our game the engine architecture, and I will pass the word to Alex here, who will talk about code a bit. Go.
Okay. Don't worry, it's not gonna be that scary. I'll try to have very simple diagrams. So first of all, let's talk about what a game engine is without any structure. There's a few terminologies that are going to be used during this presentation, and some of them you're familiar with, and some of them are more ambiguous, like they're used interchangeably. So, for example, framework and game engine sometimes are used having the same meaning. For the context of this presentation, we're going to isolate framework as the opinion of the engine, like how it dictates the structure of the code. Everything else that's contained in the game engine, like the rendering engine, it's also using the same word. We're going to define it as anything that has an engine part, as something that does something computationally difficult or hard. Like the rendering engine, you can imagine there's a lot of graphics there going on, there's a lot of math, same thing as physics engines. I can imagine for sound engines the same thing, I've never seen one. And then the important part of an engine, other than the framework and the rendering stuff, is the tooling and the game mechanics. Now, by game mechanics, I mean that when you're using a game engine, you expect to find things like colliders, like a player character, like being able to change scenes, like this stuff. These are commonly used mechanics between games, and if you have to use them, if you have to write them from scratch at time in a game, you duplicate the code around that game you have. Again, most of it will be better. So a game engine is supposed to take care of that, and the main difference between engines is the framework they're using, the way they let you code your games. So for this presentation, we developed an example game engine, very basic stuff, very beginner stuff, just to try to the principles that we'll discuss about. And we're going to focus on the framework part, so we can discuss a bit on the architecture of the framework. And I think I should go to the demo here, but I haven't seen my notes here. So let's switch to actually we have a So this is a very basic demo from with this engine. We have more, but let's have this one. So in this example, what we see is 4 very distinct behaviors. We have a basketball that's spinning without moving. We have 2 basketballs that are moving, but only one of them is spinning. And of course, there's the rendering part of just being there on the screen. So these 4 behaviors, if you notice, they are different combinations of these behaviors. One of them is spinning and moving, the other one is moving without spinning, and the other one is just spinning. So there's common behaviors. Of course, this implies some form of composition, which we do favor position over inheritance in this framework, and in most game engines this is the case. And the framework, the architecture pattern that we chose for this framework is called ECS, standing for Entity Component System. So an entity, think of it just as a plain container. Its sole purpose is to include components, and the components are also just data. There is no logic in them, there's not supposed to be any logic in them. They could very well be plain JavaScript objects just with key values in them, nothing else. And these two are meant to be used together. And the system is where the logic of the game will be. That's where everything that you write is going to be, and the way you combine components. Afterwards, you're going to give the different behaviors in the things that we are using. So this is an entity with components. It can have an arbitrary number of components, and the combinations can be endless. And this is an example of a system. So let's take, for example, the rendered system. In this case, we want to develop the rendering behavior. Now there's three main elements in this picture. One on the right side here, this is supposed to be the logic. This is where the code will be. There's two methods in here. There's initialize and update. Let's focus on the update, which everybody's familiar with. This is supposed to run once per frame. And any system will do something in here, something different, depending on the behavior they want to describe. Now, how is this applied to everything in the game, and how is it differentiated? The other two elements that the systems have is a list of entities. It's not the list of every entity in the game. These entities are filtered, and they're filtered by the components that we assign on the system as a filter. These are not instances up here. This is just the description of the component. So we say that the render system, it needs any entity in the game that has at least the transform and the sprite component. We don't care about anything else. So every entity that gets filtered, that passes this filter, is put into this list, which is handled by this render system. And then the system will look through all of this, and on each iteration, it's going to pass the current entity as an argument in the update. And inside the update, you will work on that specific entity and do whatever logic you want to do. In this case, let's say that you want to just place a sprite on the x and y values of whatever values are in the transform component. So this is how the systems are supposed to work. And this is an example flow information. So we have one entity, and it contains, we're trying to describe a car in here. So we have, the car has an engine. So we have an engine component and a wheels component, which is supposed to pull information about how many wheels it has, the width of the wheels, whatever we want to include in there. Then we have a transform component and a sprite component. Now let's start with the accelerate system on the side. It has filtered this entity into its own entities because the accelerate system wants to work with only entities that contain an engine, wheels, and transform components. So it will take the, let's say, the power attribute from the engine component, and it will do something with it, maybe some calculation to get how many pixels it needs this entity to move across the screen. And then it will update the position of the transform component. And that's it for the accelerator. It will do nothing else. Then the render system will take over. It has this component, this entity, filtered into its own entities because it contains the transform and the sprite component. And then it will just render the sprite on the x and y values of the transform component. Now, it just so happens in the previous frame, the x value was slightly to the left, and the next frame is going to be slightly to the right, and you get the illusion that something moves across the screen. So this is a very simple example of how two systems would work together to give you a behavior that looks familiar to humans. Then, from here on, it's just defining things. There's no coding, there's nothing, it's just, the whole thing would be just placed into a JSON file, and everything would be data-driven. So you could describe the car by placing the components and changing the properties, or you can describe the motorcycle by having the amount of wheels as 2, etc. And of course, you can't just describe type of vehicles, you can go a step further and describe the models of cars, because you can change the power of the engine and the width of the wheels and all the other things that you might have put into these components. And this is exactly what we've done here. This is a demo of, that we developed with that engine. Every car has exactly these components, the engine component, the wheels component, and there's an accelerated component system that does these calculations. And of course, there's the parallax mechanic, which is done in a similar way. There's a parallax component placed on any entity that we want to use as a background, and it just has a speed property. So we have a few entities that are used for background. That's how parallax works. And then the parallax system will fetch all of them, will iterate them, and we'll just start moving them on their own speed. And it also uses an object pooling mechanism to just loop everything, so we don't just loop once going away. That's it. So this is another example built on the same components as the first one with the particles. There's an extra component here which is the orbit, and it also takes parameters for the center of it. And there is an orbit system that it will just start placing the entity somewhere along the circle around the center, and on every frame it will just move a little bit forward. So these are very simple. I'm supposed to show the code for this. For those that are interested, this is going to be the more important. I'm trying to get fast through this, and I have to figure out how to do it. So first of all, I'm going to let's start from the game side. This is the game file that we describe all the entities we want the game to work with. First of all, we just create a new game. We pass in some config, that's the other one. Then we assign the assets that we want to work with. And then we go to the entities. And this is an entity. This is just data. There's no new instance created here. There's nothing. Even the component is not an instance. It's just the prototype of the constructor of the component. Somewhere along the line, when the game is initialized, these are going to be transformed into actual entities. Something is going to create a new transform component that takes it into a new entity that has these parts in it. But for now, we just describe this as data. Here we have the different basketballs, and you can see that only one of them is rotating, the other one is just bouncing, and then the other one is also bouncing and rotating. So these systems are agnostic of each other. These behaviors exist without even caring about any other behaviors on the same entity. Once we group the components and the filter of some system manages to get an entity, it will apply whatever logic it has on that entity. Then this is the entities for the planet demo. And from here on is just the entity stuff. You have to register the systems into you start by creating the scenes that you want to work with. Then you assign the systems to each scene that you want to contain them. You add the system to the game and you initialize, and that's it. Now, we can take a look into what a component looks like. So let's go with the rotating component. So that's it, just data. There's nothing else. This could be a plain JavaScript object or implementation with some expectation view, or to have this more abstract. But it's supposed to be just data. There's not supposed to be functions here, nothing that you could try to call, and nothing, just data. And all the components are like this. And let's take the rotate system, for example. It has the filter here, transform and rotating, so any entity that contains these two is going to be filtered into the entity that this system is going to work with. And then it gets the components, so it can access the data, and then it simply modifies the transform. And that's it. It doesn't care about rendering. It doesn't do anything extra. It just cares about applying the rotation logic. For the second game, so I'm going to show you the engine. Yeah, this is some not physics-based properties here. I wasn't trying to make them Gran Turismo. So there's power meant to be used like a horsepower, and then the efficiency of the engine. And then there's some weird logic in the accelerate system. Don't pay attention to the logic, it's not accurate. And then you get some distance that you want to apply to transform and you move. That's it. That's how an entity component system works. Now, how is it implemented? I'll try to be quick on this. So this is the game class. This is the engine side now. It's the game engine side. The game class is meant to combine everything together, right? So it takes care of the scenes that it wants to work with, and some visualization logic. It provides some extra functionality about adding and manipulating these things. So the game is going to use scenes which are a layer above what we call worlds. Worlds where the entities and the systems link. The scene is just implementation trick to add pixie stuff to there because the whole engine is based on pixie. So every world contains a lot of entities and a lot of systems. And that's how you can separate between different scenes. You can create different pieces of the world and have different stuff in there. And this is where you place the new entities, and also this one is where it manages the filtering logic. So we filter the entities that exist by the components that are passed here. And now let's take a look at the entities. It's just a class that has nothing in it. It's meant to hold components, and of course it can be used as a node, so you can create a tree, but that's irrelevant for now. But that's its core purpose, to create components, and then it provides some logic, so you can add components, move components, maybe get a component with it. That's all. Then the component is an abstract class. It's meant to contain data, so there's nothing in here, just a reference to the entity where the component is contained. And then we have the system, which is another abstract class. It takes the components filter, which is empty in this case, so you can when you extend it, you will populate it with whatever components you want. And it has an abstract update, and in this case, the method that we chose for visualization is this one. Every combination can be used. And that's it. That's how an empty system is implemented in a very basic way as a framework. Now, so let's put this all together into the architecture of a game. Again, simple things. We start off with a layered architecture. At the bottom part, we have the third-party libraries. These can be the renderers, in this case, some state management library you want. Whatever you don't want to develop that's out there, you can reuse the basic there in the third party. Then we have the core. The core is supposed to hold anything that's out there, but you still want to develop it. Like if you want to develop your own renderer, you would place it there for some reason. If you want to develop your own sound engine, you would place it there for some reason. But it can also contain any other things that you want to have your engine, which you may not like what's out there, or it may not exist. For example, you may want to have like an event manager in there. Then we have a vertical layer on the side, which is utilities. That's common in every architecture. You have some common parts that are going to be used by everything. Maybe you have a logger in here. And then up top, we have the UI layer and the game foundations. Now, game foundations is what whoever is using the engine is going to be working with. It says the game mechanics that we expose. In this case, we expose the transform component and the transform and the render system and the sprite component. These sort of things. You may expose like a game, a player, a movement character or something. Whatever you want to expose that's common in games and you develop, it's going to be through here. And the UI is the UI. Buttons and stuff that you have implemented in your own framework. Now, framework is also placed in the core. And I'm going to expand this diagram to see the contents. And this is where the framework is placed in the core. Then we have the game class that's exposed up here because that's where everything needs to be brought together. Resource manager and everything else that I described before. Of course, the more you progress with the engine, the more complex this thing is going to become. It's not This is a very basic one, as I explained. And yeah, that's what a game engine architecture looks like. I think that's the last slide. So yeah, I'll pass it over to Viktor.
Yeah, I think that what we did wrong is that we started before we started the presentation. Anyway, yeah, I'm just older inside than outside. Anyway, so why we just talked about like this example, specifically ECS, for a few main reasons. First one, entity component system is one of the, I would say, most developed theoretically game engines architectures, frameworks. I mean, there are a lot of different approaches to make games, and with game development in general, it's very diverse. So I would say that every single developer has its own framework how to do stuff. The other one is because it's heavily favoring composition, which is very, very convenient for especially iGaming industry, where you build a lot of games that are similar in some ways, and you need to maintain them for a very long time with very diverse environments. In this case, in the perfect world, you will just have a bunch of games with some entities and components, and all your systems are engine-based, and then you have full control over your games, and you can easily update them to the latest versions, and then maintenance becomes not a burden, but it just works. That's just in a perfect world. In the real world, it's a bit different. But still, even though this example of an engine was very more or less quick to do, and it was more like just to show you the simple way how it looks like, to actually build it, it will require some time. So not everybody wants to build their engine and wait want to start building games. So we will have an initial question like if you have any alternatives, and in general we have plenty. Like just to name a few, yeah, Unity, Godot, Default, Canvas, Pacer, Babel.js. Like some of them are totally free and even open source. Some of them will require you to pay something for a full package or for partially part of their functionality. You still have something to choose from. Of course, they are all different. They all implement the framework, their own framework, differently, and it will also influence what are your capabilities to scale development, how to make it more scalable for your specific case. Like just to give a very brief overview comparing to what we just showed. Like Unity has something that from far away can remind you of ECS system, and you have game object instead of entity, more behavior instead of component or just behavior, but we don't have systems. And their behaviors are more like a system and a component together, so to say, because they have a dedicated place for configurations and they have code. So it's all designed for a visual editor so that you can review your scene, you can see your game objects, you can see which game objects there, what parts of it you can configure, and that's the configuration part, basically part of your class, your properties. And then you just, your game object is defined by the set of your components. Like it can be transform and behavior. Transform, like for positioning in a space, rigid body to be for physics, sprite for images, and mesh for 3D objects. Like Godot, one of the rising stars of in-game development, and only has a totally different approach. It's a totally inheritance-based engine where everything is a node and and positioned somewhere in the hierarchy of different functionalities provided by the engine. And when you start to develop here, instead of composing your component, your new features, you would need to find which part of the hierarchy will be your base one. You extend it, override it, and that's how you build your functionality. So we will have here as well node 2D for positioning, collision shapes for some physics, the animated sprite or sprite 2D for images, meshes for 3D and stuff like that. So functionality is the same, but totally different approach how you structure a game. And well, it also will affect how you scale your development when you start building a company, especially when you want to build a company in iGaming industry which is heavily based on content, and the industry expects you to provide more and more new content. So you need to focus on the efficiency of creating this content. In the contrary to classic game development, when you create a game, it earns you money and you work on it well until it earns you money. Here, you develop and you go for the next one, but you still need to maintain and support your products. So when it comes to making your own engine or like using something third party, it's always a pros and cons thing that is very unique to every case. Because for proprietary engine, you have full control. So you know the recycle is built up to you. It's fully customized for your needs. It also gives you a lot of expertise in your company, but because well, you build it yourself, so people who are building are part of your company. It's also a possibility for branding and like, ownership. You can sell it maybe if you manage to do it well enough. But also it's of course very expensive because you need to hire people, you need to pay them, you need to organize the process, you need to cover all the risks, and anything happens, it's on you. So if a new iOS version for your games, your engine, you need to fix it. And depending on how fast you can do it, will depend well how fast you will react. And of course, it's an all-in investment. So once you build your engine, it's very hard to drop out because now you're entirely dependent on it. On the contrary, when you look into the market, you will get something that is basically maintained externally for free. Most probably for free. Of course, there is different payment methods, but still, the amount of work behind an engine is quite enormous. So it feels like it's free. Also, it gives you market expertise. It's much easier to hire people when you work with a third-party engine. Like Unity and Unreal, you will find developers who are specialized in that engine. So the onboarding process becomes much easier, contrary to the proprietary engine. That's one of the minuses that you should have added there. But also, well, you have little control over it. So its cycles of release is not connected to you. You can usually barely influence that. So if something breaks, well, you need to just wait, raise tickets, hope for the best. Of course, it's always general. It's not built for your case. So it's built for any case. Continue to priority risks. You never know how successful this engine is. Like if it's Unity, you can expect something in Unity. If it's something else, you never know when it will just stop. And it still will require some custom libraries. So if you will start building like video slots, for example, you will build one game, you will build a second game, you will realize that you have a lot of in common, that is your specific custom stuff, and you will still have like some framework, but now you will be totally dependent on the other framework as well to build this sub-framework. And if there will be different versions, like for example, Unity has LTS versions, like it's one of the things that you can just keep the game on the LTS version and not update it. So you will need to follow the same structure if you want to get use of it and things like that. In the end, again, everything in architecture is that's one of the things I wanted to say that about like what is a good architecture. Good architecture is not the developer that is eager to build an engine, but the one who can ask you the right questions. Because architecture is always about creating a tool for a specific job. It's not a like state-of-the-art code that just looks beautiful. No, it's always very built up to the specific use case. If you don't have a use case, you can have architecture. Otherwise, it's just more of an art thing. So, just of a small overview. Another interesting question. Like, can you raise a hand if you would prefer to build your engine if you would start building games? And now if you will want to just use a third party. Well, from both people who interacted, it's more of a third party. And it makes sense, because in 2024, building your own engine feels a bit like an overkill. So you really need to have a justification to build your engine. So that's another, how I would say about an architecture, like a good architecture is not the one who can build your engine, but the one who can justify you building an engine, because you need to justify that kind of investment. So we are coming to the closure of our talk. Just a few conclusion talks, sentences. So what we learned today? We learned today that building games is hard, maintaining games is hard, and I would say even harder, because that's the one point that people usually forget about. They build the game and they're happy, and then they realize that it's not the end. Architecture is important. Well, non-brainer. Making demo is fun. I'm sure that Alex was super fun working on this demo engine. Market is quite developed. You really have choice now. It's not the same as 20 years ago. You actually, well, you had to improvise a lot. Now, well, so many tools. They're so developed that you have really a lot of choices to make. And decision making is hard because you have a lot of choice. And again, there is no correct decisions in game industry. Game development is very diverse. It's there is literally no right choices. It's all up to you. So, using this opportunity, I also want to tell that we are hiring. Actually, we will have a game engine developer position, so it's a hot one. It can close in time. So if you're interested, go to the talenthubfame.com. Anyway, that's it. Now we are coming to questions. We also have a few goodie bags. So if you have a question and you want to ask it, we can give you a goodie bag. We have our assistants who will provide them. Okay, questions? Yep.
Good question regarding the engines that you mentioned. So now you have an experience of 12 years and more in this industry. Which of the two solutions do you see now more revenues? The proprietary engine or the
More what?
more revenues, more benefit? If you have to choose one of them now,
Yes.
or one is another game to the group, what solution would you choose?
Yeah, not to say things contrast to what I just said. It all depends on the task at hand. So, like, if you're building like a new mobile game, there is literally no reason for you to build your engine, because the provided solutions are more than enough for you to do. So even like the open source solutions that have a quite good community, like Go or Default, they provide you more than enough things to build your games. So yeah, it's a question about like for example iGaming industry, because this case is quite unattended much with games, because again games, the engine's mostly focused on how to make stuff, and it's not that focused on how to scale stuff. So when it comes to scaling, it's usually up to you to figure it out. So first of all, you look at the platforms. Like when you talk about like web game development, only a web engine can provide you the level of control you might want to actually be, if it's your focus platform. And like Unity can create web builds, but it has much more limitations to what you can actually deploy there, so it can run, especially run on mobile, because Unity focuses on web builds for desktop, and for mobile they have native mobile apps. Why would you bother? While like Default and Godot are much better in building web builds, even playing on mobile, because they're much simpler, they're smaller in size and stuff like that. But for example, Canvas is a nice web-based engine, but well, its experience developing is a bit different because it has a totally web-based even editor with like using JavaScript. You can use, like it's much harder to use TypeScript and stuff like that, so you are bound to how they do stuff. So considering them, yeah, so that's why I say that there is literally no simple solution. It's very up to you. Like I'm an architect, so in my interest is to build new stuff because I'm curious about it.
There's one key factor here. We're talking about web game engines, which is JavaScript. You can skip a lot of major pain in the engine development. Like all the rendering stuff you can just get it. It's out there. So we really talk about building a framework layer, and then building some common features on top. So this is not as expensive as it would be for a company to create a full game engine to build the next Call of Duty.
Can we say that today there is no more good reason to create your proprietary engine? At least if until you don't have
There can
any
be a good
specific-
reason, but if you take all the reasons, the good reasons are very few. Like
That's
they're very
so
specialized.
more we move forward in the years and the technology evolves,
Yeah, of course.
more there are no
things out
reason
there
to
are more advanced.
Yeah. Obviously, considering a game like we have right now, no? I suppose that during this year, obviously, if this question was 10 years before, most probably you could say, yeah, those three engines doesn't have this, and this, and we need to create our own one.
And also they allow customization.
Yeah, okay, yeah,
You
of
can build
course.
components on top of it.
Without
Your-
reinvent the wheel, I mean, you know. So I got your point. I got your point. Thank you.
Yeah.
So where would you think that using a proprietary game would apply to this? Like for a large scale projects?
Yeah, I would say that the more unique your case, the more chances you will find the reason to do it. Like with cases like again iGaming, you probably end up with building your own framework, implementing your own framework based on some of the engines that already exist. Like I would not reveal rendering part because we have Pixie, we have VGS, we have everything we need to render stuff. There are a lot of sound options that you can reuse as well. But this framework that will help you how answer this question, how you're going to scale it, that is not that developed. So you need to figure it out. Otherwise,
There's also another thing that I'm going to speak like an AD developer now. If I were to make, if my business case is to make games that are all like text-based for some reason, like I wouldn't choose Unity. Like it's an overkill. Because you would develop probably something specialized for what you're trying to do. If you were to make some, I don't know, isometric RPG, then yes, you can use Unity. And then you can also use Unity for the racing game. Okay? But if you want to make a very, very physics-based simulation of racing, it's very specialized. Right? You probably would look into developing your own, at least modifying the engine you're going to use. Because that's very specialized. You're not going to get the libraries that they give you in engines are the standard libraries. They just cut a lot of cases. When you're looking at something very specialized, like in iGaming, that you have very specific types of games you want to create, then it makes sense to create your own engine because then you have full control. And depends on your business case, you might have more benefits to it.
and even for that, we will have before. It's lightweight and